Yes.
Okay, perfect. Let's get started. Okay, my name is Robin Teigland, as mentioned. I'm a professor at Chalmers in the Department of Technology Management Economics, and I'm the project director of this project, which we called Ocean-LSAM, excuse me, which stands for Organizing the Circular Economy Through a Network of LSAM, or Large-Scale Additive Manufacturing, Microfactories Recycling Ocean Plastics. While we're speaking, if you're interested, we also have a website. I'll just show you briefly because we have a number of partners and most of us are here now. But our core team is, we have a group of 3 people from RISE who will be presenting today as well. Johan Landberg, Woodrow, Wiest, Mohammad, Rouhi. And we also have other industry partners already on board. We have Jon Erik Borgen, who is here from Ocean Tech Hub in Portugal. We have Jonathan Dicker, who is here from Artex. And we also have Carolina Teigland, who is here from Ekbakken Studios. So those are the team who are here with us today. But this is also our website in case you have more questions about what we're doing. So if I get back to the presentation, what is Ocean Tech Hub and our vision? So just briefly, the idea is that we would very much like to work with developing tomorrow's global network of circular economy microfactories. And I'll get back to what we're seeing as a definition of a microfactory, but the whole idea is how can we enable or facilitate to produce large products that are designed by Swedish industry, but that are produced from local recycled polymer waste streams. So accessing the polymers that are there, the waste to plastic, where it is locally, and then turning that into products in a local factory. And the idea is to be using large-scale additive manufacturing. But this equipment should also be supplied by Swedish industry, as we know that there are quite a lot of firms working in this space as well. And through our vision, we hope to contribute to both Challenge Area 1 of Production 2030, which is the reduced resource waste along the entire product life cycles and value chains, but also clearly contributing to fulfilling the Agenda 2030 SDGs 4 goals, primarily 9, 11, 12, and 14. So this is our overarching vision. Now, we've been working in our feasibility study and working towards this Step 2 project, which we'll be filing for our application. And there, if you were to take a step back and say, what is the goal for this project and how does that contribute to Sweden's competitiveness? And the idea is, how can we really push the boundaries in terms of digitally transforming manufacturing? And while we're doing that, really fulfilling the SDGs. So this is a sketch of a microfactory in Portugal, which Ocean Tech Hub has been working with. And is it possible to dream and say that you could bring in a waste stream on one end and then shred it up and grind it up and turn it into some pellets and then turn it into some type of product for the local market through additive manufacturing? So this is a vision that Ocean Tech Hub has had now for about 4 years. And this has been spreading because we're now working together with Ekbakken Studios in Sweden, which is one of the partners. And here, Ekbakken Studios would like to say, how can we design a product that then could be sent out to local microfactories using waste streams and then producing them locally for the local market? So can we create a global network of circular economy microfactories? But clearly, there are so many challenges to getting to this vision. Today, we have a very low plastic recycling rate. In Europe, it's around 32%. We are tackling the challenge of fishing nets that are made of polyamide, these PA6, which today there's only about 1.5% of fishing gear is recycled. This is a huge issue. Every day there are tons and tons of fishing nets being used. And as we know, they can end up as ghost nets if they're not taken care of properly. So this is one of the major challenges that we're taking on. In addition, you can't just, grind up this stuff and throw it into a 3D printer. There are very high material demands. And so we know very little about what type of stabilizing fillers will work the best with polyamide. Well, quite some work has been done with PP. PA materials require, there's more difficult material to work with. And as we've seen, the companies out there working with PA or with ocean plastics really haven't taken on this challenge of PA6. Now, while you create the pellets, the next challenge comes in that there are tremendous challenges to actually printing with this material. You have warp, you have creep, you have all different types of issues. And this, what you see here, is a piece of furniture that Ekbakken has designed, and tremendous amount of challenges, which leads to a lot of waste in this process. So what's been going on is very much kind of shooting from the hip, trial and error process in terms of trying to get this whole aspect of taking plastic and grinding it down and then printing it out. And as of today, if we look into how well circular economy and say microfactories, how far we've come, a lot of it is very much kind of in the conceptual phase. We have very little empirical evidence of how we can actually make this work. So this is the background to our project. And if we look forward, then what we've been, or look back, actually, I say, are in the middle of what we've been doing in this step 1 6-month project, we have 5 work packages, where the first one is actually looking at the recycling of the ocean plastic, the ocean polyamide, turning it into material that could be used for large-scale additive manufacturing, which is then taken care of in work package 2, which is how can we actually then design and produce this using this material. And then the third one, well, how can we streamline this process as well? Can we develop some computational models to facilitate the whole process from designing something to actually having it printed so that we can reduce the amount of waste? So one of the main goals here is how can we exactly streamline this process, remove the waste, and ensure that we could actually create these microfactories. So the last work packages is where talking about developing the concept and then this project management and application, which we'll be putting together for step 2 application. I think what I would like to do now is turn the floor over to my colleagues, the partners in the project. They're going to be presenting briefly what they've been working on. So we'll hear from the work package leaders 1 to 3, 4 to 5 minutes each. And then we'll hear from our partners where they'll just give a brief presentation of themselves and why they're interested in this project. Just before we start, I can just mention that the focus of this step 1 has been very much within the furniture industry, as this is one of the ones that has made the most advances in this area. So let's see, let's hear from Johan. Johan, are you there? And I'll stop sharing my screen, and I think Johan will, I'm sorry, I'll continue to share my screen, and then Johan can just step up here. Great, thank you.
Yes, I'm here. Okay, so my name is Johan Landberg. I've been working at Wiest for roughly 6 years, and we started collaborating with the Ocean Tech Hub during 2022, and it panned out in this project. So what we're looking at now is a few steps in the material development for this 3D printing. So we are starting with on the top left corner we have the chopped up fishing nets, polyamide fibers, which has to go in the dryer, which you see in the picture, and has to be dried. We usually dry it overnight, and then we feed it into our compounder, and we mix it with talc in this case, and it comes out as 2 strings, and it has to be cooled down, and then we pelletize it. And yeah, for this project we haven't done any mechanical property testing yet, so that's why we don't have any good looking test bars. The test bars is from another material, so it doesn't turn black when you injection mold it, just so you know. And then we can test the mechanical properties to see how it behaves and what kind of effect the filler has on the material, as in not only it shouldn't only be printable, it should also be durable and sustainable. And I think we can skip to the next slide if I have. Yeah. So in this project we are looking at different fillers. So we want to find a filler that is also sustainable, which hopefully also is recycled. So that's why we've been looking at, for example, glass fibers from wind turbine blades, which will be a huge problem in the future with all the wind turbine blades that has to be recycled. We have also looked into rock wool, which we will do experiments on as well. So yes, a few different kind of fillers, and if we have other partners in the project which have other waste streams that could work as fillers, that would be super interesting for a second step as well. So yeah, I could say that the goal in the future with these micro factories is that you can take a locally produced both filler material and also the polymer, and combine these together and make the material which hopefully will be suitable for printing. And this project, I think, will lay a bit of a foundation on how it can be combined and what to look after. And yeah, we'll also look at characterization, as I said before, some tensile testing, impact testing, and also MFR, which is melt flow rate, which gives you an indication on how it behaves on how it flows and so on. Yeah, I think that's. Oh, you're muted, Robin.
Sorry, doing too many things at the same time over here. Yeah. Thanks so much, Johan. That was great. Yeah, and we'll have time afterward for questions. So hold on to your questions. I'm sure many of you have some. So great. Okay, let's go to the next work package, which is work package 2, which is looking at if we have created now these pellets for LSAM, what are the next challenges related with that? And here we have Woodrow from RISE as well. And I think, is he online? I'm not sure if he would come online yet. I can't see who's in.
No, I cannot see it.
Okay,
he's online.
Great. Yeah. Great. I was then thinking maybe Carolina from Ekbakken Studios, you're in the picture here. Maybe if you could just say a few words about what you've been working on with Woodrow here. Thanks.
Yes. Yeah, as we see, here we're test printing a first batch with fishing nets. And I believe that this was with glass fibers coming from a recycled boat. And we see here that we don't really have the nice surface that we as Ekbakken Studios really want to have for our furniture. And like challenges we have is the first layer adhesion is very difficult with the polyamide shrinking. So that is something that we want to work with for work package 2, trying to see what can we do can we optimize the printing speed and layer height and layer width, so on, to find the best results. And we will be using IR cameras to do to get specific real-time data to see the actual temperatures of the materials when we're printing. And this knowledge and data will go into the simulations for work package 3 that Mohammad will talk about.
Yeah, great.
I think I covered some.
No, that was great. Thank you, Carlene. That was very good. That was excellent. And I think what this shows that we have a very good connection with industry, tight collaboration between RISE and our industry partners. So that's great. So what we've looked at so far is looking at taking these fishing nets, grinding them down, turning into pellets, and then putting them into RISE's large-scale additive manufacturing machine there, and then coming out and then saying, okay, well, how can we then really improve this process? Because you see there's a lot of warping, a lot of issues. And so the idea is we'll be collecting data. And what we're going to do with this data, I think what's really exciting is the next piece that Mohammad has been working on, who's come into this project now, and he'll take us on a computational model journey. So Mohammad, take it away. Thanks.
Sure. Thank you. My name is Mohammad Rouhi. I'm from former Sverige Seacom since 2012 and RISE. I'm quite new to additive manufacturing process simulation. I'm coming from a background with polymer composite process simulation. So it was a lot of nice challenges here for setting up the process of additive manufacturing. So basically, we have a part that's been designed, for example, with the backend, and then we turn it into a mesh, and they will also provide a G code that from that we have a Python code that will generate the event series of this G code that would go through the printing and would have a kind of a cross path with the mesh that we will provide, and a concept of element activation will generate the print path through the part that we will see. The simulations is being performed in Abacus software with the additive manufacturing plugins that they have provided since 2017 and added to this system. And the idea is to provide distortion and residual stresses from the physics that are happening. So basically what we would like to have is to do a two-step analysis, a thermal analysis, a heat transfer analysis that would generate the temperature profile from the first step where we are printing, and then with that temperature profile we will have a structural analysis where we would look at the distortion and residual stresses as a result of those temperature profile that is generated in the first step. So the capabilities that we will have here is that we would have some geometrical features that hopefully we can have some provide some defects during the printing if actually all the process parameters can accurately be used there, or can we optimize them, go on with the temperature dependent material properties that if we can characterize some, we would be able to look at them and how they affect the properties there of the final part. So in a sense, from design to manufacturing and also some maybe loading conditions after the part is manufactured, we are able to connect all the chains and dots there. Some preliminary simulation has been formed so far on a piece of the furniture part that Ekbakken has manufactured. One more click, Robin, please. So here what you will see is that in the left we have thermal analysis of the part during the print, where the temperatures are being calculated from thermal boundary condition that we have with a 225 degrees print, 225 degree of the melt during the print, and also we have a 85 degree temperature on the bed on the floor that is always constant. And then on the right you will see the structural analysis and the displacement and the formation of the part, and also stresses that are formed on the part as a result of the temperature that we see on the left on the first step. I have details of the setup and going through the analysis step, but I guess I can leave it for the discussion if people have more questions. So before going through too much details here, I leave it back to you, Robin. And if people have questions, I would be happy. And it would be nice if any other people here in the meeting have any other experiences with simulations here. That would be nice to exchange ideas and see how they approach and attack this challenge, and it can improve.
Excellent. Thank you. Thank you. Well done. I think this is fascinating to see this development. I mean, you've gone so fast in terms of moving into and then quickly picking up in terms of how we can actually simulate this additive manufacturing. So what everyone is seeing here is actually, the layer for layer that's being built up by the robots, being simulated of a chair that's been produced by Ekbakken, or designed and produced by Ekbakken. So we'll get back and you can actually see that shortly. So this was what we've primarily been working with in terms of work packages 1 to 3. In addition, as mentioned, we have a few industry partners, 3. We have Ocean Tech Hub in Portugal, We have Ekbakken Studios in Sweden and Artex in Sweden. So I'd like just for each one of them to give a couple words about why, what they're doing, why they're interested in the project, and yeah, and let's hear from them. So let's start with Ocean Tech Hub. We have Jon-Erik Borgen, who I can just mention is really interesting in terms of bringing his expertise to this project. With a wide, extensive experience in the oil and gas industry and also working with simulations. So he and Mohammad have been having quite a few interesting discussions. It's fascinating there how you can take knowledge from one industry and then bring it into a completely different, application, but yet still bring that knowledge in. And I think that's one of the beauties of working in these collaborations. So let's listen to, Jon-Erik, let's listen to you. What do you have to say? Yeah. Oops, I'm sorry.
Yeah, oops.
Yeah, whoops, there we
go. So, hi, Jon-Erik Borgen. So I'm one of the founders, together with Robin, on the Ocean Tech Hub in Peniche. And I guess this is our dream project, doing what we're doing here, completing the circle, where we can see how our initiatives in Peniche with the fishing nets can be, properly investigated and turned into some local pilots, as we already have in Peniche. As a background, as you said, I'm a naval architect. I've been working with structures and the hydrodynamics and how the waves are working on the structure. So my background on the simulation is from there. And the goal, I guess, the goal we have from Ocean Tech Hub is the circular economy model, as we had shown before. And what we have done so far is that we have a few projects working with a few projects. One of them is the circular ocean, as we have called it, which is to collect and to sort and to clean and inspect and then shred into finer material, which has been challenging in itself, and then working with the RISE initially on how to compound and as it was said, with different materials we have been investigated and so far successful, at least on bringing forward some material which works, and where Ekbakken then has come in and been doing the next step of the journey. So in general, we want to see how this can be done locally, and so we are working very closely with the fishermen in Peniche. We have so far, as I said, collected something like 55 tons of fishing nets, these polyamide gill nets. Interesting story there is that these nets are actually only being used once before they're thrown away, because the fisherman wants the very pure quality when they are in the sea. So it's a really waste material. It's a hopeless situation, of course, but so we have a big amount of nets to pick up from them and to find a waste stream of. Here you see some of the process we have with the collecting, cleaning, or the sorting, and bringing in from the harbor. We have a warehouse where we try to sort even in the colors for the premium clients who wants a very special sorted material. And then you can go to the next. So we have a process there where we wash it and dry it, and then we have one of these shredders from Sweden actually, where we can then take down the material to fibers or to smaller fibers, where the extruder process can be done in the compounding world from Johan at RISE. So what we have done is we have created this brand, Penilon, as we have called it, Peniche Nylon, and it's so far successful with we compounded with where we use talc which has been working well, and which is a local product in the area of Peniche, it's shown to have a very, let's say, high. It's interesting material compared to many of the other 3D materials as we see it and as it's responded in the market. Yeah, and again, of course, we have all these goals to meet the UN sustainable goals, and we feel that we are contributing well in doing this with our projects here. Yeah, thank you. You are muted, Robin. Sorry.
Thanks. Yeah. And I think one thing here to mention is that there is a lot of effort on social sustainability here with Peniche Ocean Watch and Ocean Tech Hub. And the idea is enabling Peniche Ocean Watch working together, the Peniche community, working together with them in terms of developing new skills and moving into this digital world. But so with the sales of this material, then profits, some of the sales are actually fed back into the community to promote further innovation within Peniche, so that we can also enable this at Goal 11, sustainable cities and communities. So thank you very much, Jan Erik. Let's move on to Ekbakken. So where does this material go? Well, let's hear from Caroline Teigland and about Ekbakken Studios. Caroline.
Yes, thank you. Yeah, so I'm Caroline. I'm product designer and product developer at Ekbakken Studios, also one of the founders. Yeah, our mission is to transform the furniture industry, and we are turning waste into masterpieces. So this Ocean-LSAM project is very important to us, and we're a part of it because we want to make sure that we can have a high quality product made out of waste streams, and in this particular case, discarded fishing nets. So not only is it the use of waste materials, but LSAM being a digital production method that makes it possible to grow globally, but still produce locally, as we've been talking about these hubs. And by having them and producing locally, we're helping the planet in several ways. We're part of creating local job opportunities. We minimize shipping and we minimize the amount of waste in those places. So the simulations that we're doing in Work Package Fee can truly be a help for us in several ways. By simulating the actual product, we can forecast the outcome of the design rather than us having to print it first. You saw some of the pictures before. It's saving us time, money, and valuable resources. And for the compounding, since we really want to be sustainable, we want to look at other fillers as well. Can we actually find another stream that can replace talc that is itself a waste stream or more environmentally friendly? Why I think pebble, the wind turbine, or the glass fibers from the wind turbines are very interesting to look at and see, can we actually get a product that is as high quality as the product we get when we use fishing nets and talc. And the printing part is, of course, very important. The things we do in Work Package 2 to ensure that the simulations match the reality and being able to collect the real-time data while printing. And this is something that we want to implement in our production further on, because this data can really help us in developing further products. And we only launched last September, but have already been featured in several magazines, such as Elle, Plaza, Hem, and Vogue. So we see that there's demand from the market that will only grow with time. So yeah, we're looking forward in continuing the collaboration in this project and to see what we can achieve.
Great.
Thanks.
Thank you. Thank you, Caroline. Excellent. And just in case anybody is curious, she has the same last name as I do. Teigland is not a very common name in Sweden. Yes, she is my daughter. So, okay, moving on. Let's see. So we go on to the third partner, which is Artex. And we have Jonathan Dicker here, who can give us a little overview of Artex and why are they involved in this project. So thank you.
Sure. Excuse some background noises from the ventilation. anyways, so I'm Jonathan, representing Artex in this case, and so we will be the manufacturing partner in this project. Actually, Artex's main focus is more about fabrics and upholstering, and so we do much manufacturing of products related and including some kind of sewing and fabrics. But we are very forward-thinking owners and all that, so they always want to be in the forefront of all these techniques and industries. So now we are embarking on this new path, one could say, and yeah, so we are very excited about this whole project and see what this can bring to us. But we will also make these cushions too, which you could see in their previous pictures, actually. So it's a kind of a connection there as well. What else? I mean, by doing this kind of investment for Artex per se, we also get the opportunity to use this machine for printing during development phases and testing prototypes and solutions, and we can also find other customers for potential other projects and products that could make use of these 3D printed parts of different materials. So before Christmas we actually purchased one 3D printed machine, which will be delivered in a couple of weeks. So we were super excited about this and to start playing with it. So, thanks to Ikbaken's hard work previous to this, we could probably just kind of plug and play, because they have done so much work together with RISE and optimizing all these G code and stuff. So probably it will be good from start.
We hope so. Well, that's the idea. That's the goal, isn't it? As part of this project, is to actually enable this, as you say, this type of plug and play and streamlining the process. So we are making great advances, and I think it's super exciting that you've bought this machine. It's been fascinating to see how that, how the implementation of that works out, and that's part of this project as well, is to follow that process to see what are the challenges that arise and how can we also facilitate that. And I think what's been interesting here is that then Ikbaken and Artex have been working closely to actually even identify which machine should Artex buy. So that's been a very close collaboration there. And here again, if we're thinking about developing this global network of microfactories, I think this is very much about collaboration in Sweden and how can we facilitate this working together between startups, who are coming with the new ideas, these new digital technologies, and then established players who want to learn and grow. And this is where I think the real, magic can happen, because then we can see, well, how can these two expand then globally together? So helping each other, especially in this world of circular economy, we're seeing that we need to really work together over many different types of boundaries to facilitate the movement in that direction. So I think this is where Artex has been playing a really fascinating and great role in this project. So thank you so very much. We're just about out of time. I'll just wrap up here. Just to go through again. So step one has been a 6-month project. You've seen give an idea of what we've been working on. And if in terms of moving forward, we're open to looking for new partners coming in to help us further develop our vision or move towards our vision of creating this network of this global network of microfactories. I'm sorry, yeah, and then clearly, just to get back to the whole point is, how can we really facilitate this moving towards the challenge area 1 of reduced resource use and waste along entire product life cycles and value chains, and clearly improving the competitiveness of Swedish industry. So looking forward, we're thinking about different partners. So far, we've been working in the furniture industry. We've been discussing looking into the building industry, because since it is quite closely related. We've been even looking, Ikbaken has been talking about collaborating with Vone, which is 3D printing houses out of local waste streams. So we're looking for new types of partnerships But also, could we think about working with the energy industry, renewables, other suggestions? We are very open for looking into new use cases. It could be something completely different. I think that would be super exciting. And then also working with, say, the manufacturers of these of this equipment. So, say, working with either the hardware or the software. So if you'd like to join our team, please contact me. There's my email. Yeah, thank you very much. I'm very happy that all of you were here to listen to our presentation. So thank you. I guess it's now time for questions. So I will stop sharing the screen and we can, yeah, perfect. Thank you.
Thanks, Robin and the team for presenting. I'm gonna just stop